Welcome to today's deep dive.
Yeah.
Picture the most delicate piece of technology you own, like maybe a high-end camera lens. You'd probably, protect it from a light drizzle like your life depended on it.
Oh, absolutely. I mean, water and electronics, usually a terrible mix.
Right. But today's source material is a product spec sheet from HDTVSupply for the Bolin Technology EXU420N outdoor PTZ camera. And it retails for a hefty $8,695.
Yeah, almost $9,000 for a single camera setup.
Exactly. So our mission today is to unpack what makes it worth that much. Like how it acts as this invisible bridge between extreme physical environments and cutting-edge virtual reality.
Well, first off, just to clarify for everyone, PTZ stands for pan tilt zoom. So, I mean, this isn't just a static security camera hanging on a brick wall somewhere.
Right, it actually moves.
Yeah, it's a broadcast-grade robotic system. It moves fluidly to track action, and it does it completely without a human operator standing behind it, which is crucial.
And to understand that reality to VR bridge, we first kind of have to look at what it's actually surviving out there. Like these specs list a Sony 4K sensor, a 20x optical zoom, and an IP67 weatherproof rating.
And that IP67 rating is no joke. I mean, it means the casing is entirely sealed against microscopic dust. You could literally submerge it in a body of water without frying the internal electronics.
Oh, wow.
Plus, it operates anywhere from -40 to 140 degrees Fahrenheit. It even has this built-in preheater to thaw its own motors out.
Wait, it thaws itself. That's wild. And I read it has a hidden wiper blade, too. But here's where the mechanics kind of trip me up. Like, if this thing is stuck in a freezing blizzard miles away from a warm control room, how does it actually know what to focus on?
That's the big question, right?
Yeah, because normally contrast detection just fails when everything is, just white snow or dark shadows.
Exactly. So instead of just relying on light contrast, the onboard processor uses edge computing. It's constantly scanning the incoming pixel data for geometric patterns.
Looking for faces, I assume.
Yes, exactly. It runs its own facial analytics engine locally, so it locks onto a subject's facial geometry to maintain focus and dynamically adjust the exposure. It's basically acting as its own digital camera operator.
So stadium glare or snow blindness doesn't even matter to it.
Right, it just powers right through complex lighting.
Okay, so surviving a blizzard is one thing. But translating that harsh physical reality into digital spaces is the real trick here. The specs list a true tri-output. It sends SDI, HDMI, and IP video streams all at once. Why would a broadcaster need all three simultaneously?
It's all about redundancy and flexibility. SDI is your uncompressed gold standard for traditional live broadcast trucks. Then IP lets you route the video over standard internet networks for remote cloud production.
And HDMI is just for local monitoring, I'm guessing?
Exactly. But the real linchpin for that $9,000 price tag is this specific protocol it integrates. It's called FREED.
FREED. Okay, so this is where the augmented reality aspect finally comes in.
Yeah. Think of FREED like digital motion capture dots. But instead of an actor wearing them on a green screen suit, the camera itself is broadcasting its exact posture in 3D space.
Oh, so as the physical gears inside the camera pan or tilt, it tracks that.
Right. Internal encoders translate those mechanical movements into XYZ coordinates, and then it sends that spatial data back to the studio hundreds of times a second.
Okay, wait, I'm stuck on the latency part of this. Because if this camera is processing a blizzard, running edge computing for facial recognition, and streaming 3 heavy types of 4K video.
It sounds like a massive bottleneck.
Yeah. And setting spatial data on top of it, wouldn't that free data lag? Like, if a broadcaster wants to drop a real human into a digital AR studio on the fly, even a millisecond of lag would make a graphic slide around and look totally fake.
And that syncing challenge is exactly why FREED is built the way it is. It strips out all the heavy video processing.
Oh.
Yeah, it just sends the raw telemetry data as these tiny, ultra-fast packets over a dedicated pathway. So the VR software in the studio gets the exact pan, tilt, and zoom position just before the video frame even finishes arriving.
Wow, so the rendering engine can perfectly align the computer-generated graphics with the real-world footage, frame by frame.
Exactly. The studio software knows precisely what the physical lens is doing out in the elements in real time.
Which explains why, when you're watching like a live sports broadcast or an election night, those giant 3D graphics seem completely anchored to the physical floor, even as the camera swoops around the stadium.
Yeah, it's that seamless integration.
Right. So, why does this matter to you? You might never add an $8,000 robotic camera to your shopping cart.
Probably not.
But this is the invisible architecture powering the augmented live broadcasts you consume every single day. It's doing all the heavy lifting behind the scenes.
Merging the physical and digital worlds.
Exactly.
Yeah.
Which leaves a really fascinating kernel to chew on. If AI and spatial protocols can now flawlessly track and blend real humans into virtual environments without human operators.
Even through the harshest storms.
Right. How long until you and I can no longer tell the difference between a raw physical broadcast and a fully rendered digital simulation?